Hello, everyone. My name is Nader Kaizat, and thank you for joining us for another InRhythm talk. I'm very excited for this session, the shift left testing. It's definitely a topic that I've been interested in learning more about, and Vidal here is going to show us and talk to us a little bit more about the shift left testing. With that said, Vidal, can you, floor is yours.
Sure, thanks. So this is just a segment of a larger talk that we gave on site at the client. So the talk will be pretty short. I'm looking at maybe 10 or so minutes and then a Q&A session. We only have like 3 or 4 slides, so it'll be pretty quick. So what we're going to do is we're going to go over what exactly shift left testing is. We'll go over some strategies that we offered on site at the client to help them shift their testing left. And then we'll go into some pros, like what are the benefits of shift left testing. All right, so let's just get started. Slide over. So to understand shift left testing, we have to kind of understand what the SDLC is and what it kind of looks like in comparison to the SDLC. So in a traditional software development lifecycle, you usually start off with a design phase. Here your stories are written, your requirements are defined. Maybe we kind of decide on what an MVP looks like, or like a minimal viable product. After that, usually have like an architecture phase. At this point, we involve engineering. We decide what kind of services we need, what kind of resources are required for our product, and what kind of technologies we want to leverage for the product. Then, of course, you have your implementation, then some sort of QA cycle, some combination of feature-based testing, regression testing, maybe even like user acceptance testing if you have like active business people doing testing. And then, of course, we deploy, we maintain, et cetera, et cetera. I mean, everyone here knows what this is, what this looks like. We work with it every day. But what this has to do with shift left testing is that the traditional software development lifecycle kind of naturally lent itself to testing very late in development. And that's kind of sensible, right? The more developed your product is, the greater confidence you get in testing it. It just makes sense, right? When you test a more complete product, you know that it's working. The later in the development that you do your testing, the more confidence you get, the easier it tends to be to test, and the more clear of a picture you gain of what the product will look like once it hits consumers or whoever is going to consume it. But of course, this comes with a lot of problems. When you test late, you find issues late. Testing kind of starts to become a bottleneck. As you find issues, your engineers need to be assigned to remediate those issues. That takes time away from further feature development, takes time away from maintenance. And sometimes, unfortunately, late in development, you find design flaws. The resource needs to be dedicated to either going back and re-architecting old code or refactoring old code, which is, of course, a waste of time and resources. So shift left testing is overall kind of like a shift in methodology or a shift in thinking about how we as a team perform testing. We still have a testing phase, obviously. We need to test the final product, but as much as we can, we try to integrate testing earlier and earlier in the software development lifecycle. So let's take a look at this diagram, this kind of weird looking V diagram. What it's trying to demonstrate is essentially the relationships between the time spent developing a product or a feature and how easy it is to gain confidence in it. Like I said before, to test like the operational architecture or like the design or even the concept of a feature or an application, we need to test it very late, right? However, we can fail faster by testing specifics in the design, like the relationship between two services, as early in the implementation as possible. These early tests, of course, give us less confidence, but they should be less resource intensive, run more often and allow us to kind of sanity check our services or environments as they're being developed. On-site at the client, what we did is we had offered two kind of specific solutions to their particular architecture um, as a way of helping them shift left. And I'll talk about what those two solutions were. Those two solutions were kind of split into two categories, one being solutions that they can implement towards the end of this V diagram during and after implementation, and even one that they can implement towards the left of this diagram, kind of like before implementation. So the first solution that we offer to the client, which would have been the one that's during or after the implementation phase, is to write more and better integration tests. And they had integration tests. In fact, a lot of software companies with QA teams have integration tests. But the reality is that your integration tests are the tests that kind of give you a very granular idea of what services are working and what they're working with and what they're not working with, right? These are tests that tend to live outside of your production code and kind of exist to specifically kind of laser target the relationship between two components. And those components can be microservices. They can be like a database in a microservice. It can be like like your web UI in a microservice. It can be two different web UIs. It could be any two specific components. As much as possible, your integration test should rely on only the two components being tested in such a way that if any other part of the system were not to be active or to, let's say, hypothetically not be complete yet in the development lifecycle, it wouldn't impact the tests. And naturally, you can imagine how writing many integration tests can kind of allow us to test a product as it's being developed, right? Obviously, like developers can only do so much at once. And as you develop features and you pull new features from your backlog, your integration, your QA people or your whoever developers are assigned to writing tests can focus on what's there and not worry about what's not there. And as services are kind of being stubbed, implemented, refactored, depreciated, we'll see this kind of reflected in our integration tests, right? We'll see that a service that's currently being refactored maybe start to fail and then start to pass again as its refactor is complete. Yes. And we could take this kind of methodology even further. We could take this methodology even further because the second solution that we offered the client was to help them shift their testing left, especially left of like the implementation period, was to implement behavior-driven development. In a lot of QA cycles, kind of features tend to have their tests stubbed out, but not finalized until there's like a solid implementation to test against. And this kind of goes into that late testing kind of QA cycle workflow that you tend to see at a lot of software companies. And the reason why is that your tests are generally very tightly coupled to their implementation. It's either that or requirements are not very clear early on in the implementation, and they get kind of ironed out throughout the development process. But what we can do is we can shift our tests kind of left, we can shift left in our test design by writing tests kind of before the implementation during the requirements phase. And that requires, of course, very, very good requirements. It requires a very active, proactive product team or business analyst team. But what you get in the end is you get tests that are very kind of laser focused towards the user experience and not so much the architecture. And why is that important? Well, to talk about that, let's sort of talk about first what behavior-driven development is. And I'll refer to it from this point on as BDD. BDD is a kind of like a testing, or rather a software development methodology. It was a large portion of our talk over at the client. One of our agenda topics was bridging product and engineering with BDD. And what it is it's kind of like an evolution of TDD or test-driven development. And both of those are development methodologies that involve writing your tests before you write your implementation or before you develop any code. With the idea being that your tests act as the requirements or your definition of done. And as you develop a feature, you can run your battery of predefined tests against that feature. And of course, in the beginning, when you haven't fully implemented your feature, these tests will fail. But as you continue to develop it, these tests should one by one pass. And you define your feature as being complete when the tests all fully pass. What makes BDD different from TDD is the specific testing tools that you use to write your tests. Specifically in BDD, you tend to write your tests in kind of like plain language using what we call like the Gherkin syntax, which there was a slide on the for the client. I'm not going to get into it right now, but the idea is that either your product people, your product owner, or your business analysts can write their tests, can write the tests in plain language as part of their requirements gathering, as part of defining user stories, as part of the, from this diagram, the requirements and architecture phase of the SDLC. In this way, we can shift our test design to the very beginning of the SDLC, basically, which allows us a lot of time to kind of iterate on tests, to ensure a test quality, and to kind of reduce the delay in test automation / implementation. And again, like I said before, the sooner you can run tests, the easier it will be to find defects early and fail faster. So let's just sum up what some of the advantages of shift left testing. I kind of went over them already, but I'm going to just say them as kind of a wrap up here. So like I said earlier, with shift left, you're testing earlier, you're testing more often. When you test earlier, you can find bugs earlier and you can fix them earlier. You can also find design flaws and adjust before you commit to bad or inefficient architecture. These benefits all work together to sort of reduce the cost and time of development. You're reducing your bottlenecks, you're reducing time spent redoing old work. And additionally, because shift left requires more teamwork, you're naturally increasing collaboration. You need to involve QA earlier in the process. You're involving product and business in the QA process. And it is a team mindset. One of the great things about BDD and one of the reasons why we were able to kind of recommend it to the client was that it allows anybody to write your tests. Product, dev, QA, even DevOps can kind of be involved in the process of ensuring product quality. And that's what it's all about, right? It's ultimately about product quality. When you shift left, when you test early and often, when you include the entire team in the testing process, the quality of your software product naturally improves. All right, that's kind of it. I think that was 10 minutes. Yeah, so like I said, this was kind of like a short talk, but at this point, I'll take any questions, any comments.
So, Vidal, I have a question.
Yeah.
So what would be kind of like the differences, in your opinion, between like TDD and BDD? Like what makes BDD better?
Yeah, so TDD is still like, imagine that you are writing a microservice, right? In TDD, when you write your tests, you're writing code, right? Your tests are code. They're unit tests or some sort of, usually they're unit tests in TDD, which again, number one, unit tests are very insular. They'll probably live inside your product, live inside the service itself, and they'll very specifically test that service only. But you can, of course, have a TDD methodology where you're writing tests like maybe integration or end-to-end tests before a product is developed, but they are ultimately code. The difference is that in BDD, your tests are not code, they are scenarios, and they exist in a certain format, but ultimately they're plain text, plain natural language files. We call them, like in most tools that use BDD, they're called feature files. And these feature files are like, they can be written in a text editor, but ultimately most BDD tools allow you to kind of commit them to a code base, and then we'll be able to read them as if they were kind of like parse them into code. But that's the real difference. The difference is that in BDD, you're writing natural language and not code, but you can then take that natural language and kind of translate it into code eventually. I hope that answers your question.
Yeah, cool. Thanks. Thank you all for joining us today. And if you're interested in more thought leadership across different platforms, we have iOS, Android, web, and backend. We always do every Thursday, we do a lightning talk at 5:15 Eastern Standard Time. And next week, we have one of our rising rock stars, Hamid, who's going to be talking about system design in iOS. So make sure you tune in for next time, and have a great rest of the week.